Now in the last video we took a look at this problem of a truck moving away from a depot, and we thought about how we could find its average velocity and instantaneous velocity at a particular time. Now what becomes kind of interesting here is that we could start to imagine finding instantaneous velocities for the truck at a whole bunch of different times, right? I mean, it seems like we could really I could have said, what's the speed or velocity of the truck at 3 hours? What's the velocity of the truck at 2 hours? What's the velocity of the truck at 1 hour? What about 1.5 hours? What about a half hour? I could do all of these. And you could start to imagine that, like, if I gave you guys a homework assignment where I asked you to calculate the instantaneous velocity of the truck at a half hour, at 1 hour, at 1.5 hours, at 2 hours, at 2.5 hours, at 3 hours. Eventually, many of you would just get so ticked off, you'd just go, screw it, I'll lose the points. I don't care, I'm not doing all of that work. Think about how many times you would have to compute this. So instead, let's take a look at example number 6 and see if we can find a way around a situation that would be like that. Can I find instead a general formula v of t? That is, the instantaneous velocity at a mystery time yet to be named. And can I do that for this function back in example number 5? Well, let's see if we could actually go ahead and do that. What if instead of finding the velocity at 2, I wanted to find the velocity at mystery time t, right? Like, you know I'm going to ask you a bunch of questions, so you're just going to hold off on filling in that value yet. Well, could I think about what's going to change and what's going to be the same in this calculation process? Notice that I would still have to set up my limit in the same way as I did before, right? Everywhere that there used to be a 2, now I'm just leaving the mystery yet to be filled in value of t. And of course that's going to change a little bit of what I'm going to get in the next step, because over here now I'm going to actually be able to say that, well, I'm really going to have 1 minus 5 times t plus h plus 15 times t plus h squared, and then that's going to have to be subtracted, or will be we'll have something subtracted from it, and that'll have to be s of t. I can't just type in what s of 2 is. But since I don't know what t is, I don't really know how to simplify down this anymore. So I kind of am going to have to write all of it. I'm going to have 1 minus the 5t plus the 15t squared, all over h. Now, while this looks much uglier than what we had before, I can still think about simplifying it in pretty much the same way. Let's see. I can distribute some stuff up at the top. I'm going to get 1 minus 5t minus 5h. I can get 15 t squared 2th plus h squared. If you're not sure again about how I'm getting this middle part, actually write out the t plus h 2 times and actually do your distributing. Over here I'm going to distribute my negative sign, and so I'm going to get minus 1 plus 5t minus 15t squared. Okay, so all of this is in the numerator over h. Now, I'm going to go ahead and, for the sake of space, I'm going to try to simplify down here a couple things all at once. Let's focus first on our constants. First, we can see that really the only constants we have right now are the 1s, right? And so those 1s are going to be able to cancel out kind of immediately. That's really nice. The 1s are gone. I also see here that I have a minus 5t and a plus 5t, so those are gone. I can also see here that when I start doing some distributing, I'm going to get a positive 15t squared and a negative 15t squared, and so those are going to be gone. So let's think about what we really have left. What I'm going to have remaining is, well, a minus 5h. I'm going to have a plus 30 th and a plus 15 h squared. Right? This is what I'm going to have. And I still have the same problem that I did before at this step, where I can't plug in 0 yet. But notice, everything in the numerator still has an h involved. So if I factor out an h and simplify it out, I can see that I'm going to have h and then a minus 5 plus a 30t plus a 15h. And now I can cancel out the h's top and bottom and take the limit of what I'm left with. So I'm going to have a limit as h goes to 0 of minus 5 plus 30t plus 15h, but h is going to 0. Notice only h is going to 0. T, remember, is going to be like the number 2 or 3 or 7. So t is going to get replaced by some other number later on. We're just going to have h go to 0 right now. So that means I'm going to be left with minus 5 plus 30t plus 15 times 0. Or I could rewrite this as 30t's minus 5. So the velocity at any given time is going to be given by the following formula. Now pause for a moment and just realize how awesome this actually is. Because what this tells me is that by computing this one messy limit, I could now actually really easily go back and answer part B. What's the speed of the truck at 2 hours? Well, I could compute this whole limit, or I could just say at time 2, this would be 30 times 2, that's 60. 60 minus 5 is 55. But notice at the other advantage is, what's the speed of the truck at 3 hours? Well, 85? What about at the 1 hour mark? 25, right? Like I can compute everything really, really fast. So this is great because now I can find any time really quickly, and I only had to compute one slightly worse limit. So this becomes really, really, really nice to be able to use. So as I state down below, we've seen so far now that this limit has come up in two different applications. We can find with this limit the slope of a tangent line, and also we've related that to instantaneous velocity. So this becomes such an important limit for us that we are actually, in the next video, going to give it a name.